All right, this is the second video for section 3.3, and in this video, we're going to take a closer look at the behavior of our polynomial functions graph near each root or near each x-intercept, okay? And I want you to understand that this is just another way of checking that your graph is an accurate graph as you sketch it out, okay? So in this example, we have the function f of x equals 2 times the quantity x plus 1 to the fourth times the quantity x minus 1. I've also given it in its expanded form as well, so you can see that leading term there is y equals 2x to the fifth, okay? I have the graph over on the right-hand side of this function already, okay? So what we'd like to do here is come up with an equation that represents the behavior of the graph near each one of its roots or near each one of its x-intercepts, okay? So let's start with x equals -1, okay? X equals -1 came from this factor of the function, x plus 1, and notice it's being raised to the fourth power. So at the very least, we know that the multiplicity is 4, which means we should be behaving like a quartic function at x equals -1. But I want to do one better. I want to come up with a pretty accurate quartic function to represent that curve, okay? So here's how I'll do this, all right? Since -1 comes from the factor of x plus 1, that means if I were to plug -1 back into that factor, it would zero the rest of the function out, okay? That's why x equals -1 is a zero, a root of the function, okay? So for the purpose of this problem, I'm going to plug the -1 into any of the other factors of the function that it didn't come from, okay? So that's ultimately going to lead me here. I'm going to say that y equals 2 times x plus 1 to the fourth times -1 minus 1, okay? So notice what I've done. I've just plugged -1 into the variable x in the factor that it didn't actually come from, okay? Now I'll simplify that a little bit here. Obviously, -1 minus 1 is -2, and then 2 times -2 is going to give me -4. So I end up with y equals -4 times x plus 1 to the fourth power, okay? So that's just stating that right here at x equals -1, this curve should be behaving like the equation that I have circled in blue that I've just created, okay? Now, what about at x equals +1, okay? X equals +1 came from this factor, and the multiplicity of that should be 1, which means we're behaving linearly, right? If you look at the graph right here, we're behaving kind of like a line. Well, let's come up with an equation to be a little bit more accurate, all right? So to find that, I'm going to plug 1 into the other factor that it did not come from. And I'm going to leave x minus 1 alone. So I simplify that. 1 plus 1 is 2. 2 to the fourth is 16. 2 times 16, of course, is 32. And then I can distribute here 32x minus 32. Notice that's a linear equation in slope-intercept form, okay? So basically what we're saying is that near the point x equals 1, or near the root x equals 1, the graph should be behaving like a line whose equation is y equals 32x minus 32, okay? Now, let me drive this point home here. I actually have both equations that are circled in blue and red right now. I actually have those graphed on a separate graph that's located behind the graph that you see on the screen right now. So what I'm going to do is select this curve or select this graph, and then I'm going to hit my paintbrush here, and I'm going to move it to the back of the screen, which brings the other graph up front. Okay, now notice the blue curve, that's the curve y equals -4 times x plus 1 to the fourth. See how that curve pretty well matches the behavior of the black curve for f of x near x equals -1. And then notice we have the red line that matches y equals 32x minus 32, which is pretty similar to the behavior of f of x near x equals 1. Okay, so hopefully that all makes sense to you. And again, this is just another way that you can check if your sketches for your graphs are pretty accurate. Obviously, if you come up with an equation to represent the behavior near an intercept that doesn't match what you've sketched, then you know you've probably gone wrong somewhere. Okay, so click over to practice 2. You're going to try it yourself, and then check back with my work here and see how you're doing.